Brief history of electric charges. Charles Augustin de Coulomb was a French military engineer and physicist, famous for his contributions to electricity and magnetism. In the 1780s, he performed a careful series of experiments to measure the electrostatic force of repulsion between two charged spheres at different distances. Using a torsion balance, a sensitive instrument he calibrated himself, Coulomb was able to measure the force between electric charges accurately. From this experiment, he developed what is now known as Coulomb's law, which describes how the electric force between two charges depend on the magnitude of the charges and the distance between them. This law was first published in 1785. Although Henri Cadenvash had earlier ideas similar to Coulomb's, Coulomb received most of the credit because Cadenvash never published his work. In 1798, Cadenvash later became known for measuring the force of gravity between masses, which allowed him to determine the density of the Earth and the force to yield accurate values for the gravitational constant. The world never knew about Cadenvash's work until decades after his death. In 1835, Joseph Henry invented a method for sending electric current over long distances. Long before these discoveries, around 600 BC, Thales of Miletus, a Greek philosopher, observed that rubbing amber with silk caused it to attract small objects, one of the earliest recorded studies of electricity. In recognition of Coulomb's pioneering work, the SI unit of electric charge, the Coulomb, was named in his honor in 1908. Coulomb's law. Coulomb's law states that the electric force between 2-point charges Q1 and Q2, separated by a distance r, is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. F is directly proportional to Q1 Q2 over r squared. The force is given by F is equal to K Q1 Q2 over R squared, where K is a constant represented by K is equal to 1 all over 4 pi epsilon naught, with an approximate value of 9.0 times 10 raised to power 9 Newton meter square per Coulomb square. Epsilon naught is a constant known as permittivity of free space. Therefore, F is equal to Q1 Q2 over 4 pi epsilon naught R squared. The force which charge Q1 exert on charge Q2 is equal and opposite to the force which charge Q2 exert on charge Q1. Example, find the force of attraction between two equal but opposite charges of 2 times 10 raised to power minus 6 Coulomb if the distance between them is 25 centimeters. Take 1 all over 4 pi epsilon naught as 9.0 times 10 raised to power 9 Newton meter square per Coulomb square. Q1 is equal to Q2, which is equal to 2 times 10 raised to power minus 6 Coulomb. R is equal to 25 centimeters. Converting to meters, we have 0.25 meters. Our formula: substituting, simplifying, final answer. I would love to hear from you. Share your thoughts with me. Bye.